So what is a permutation? A permutation is an arrangement of items in order. And the number of permutations, that's the number of ways you can arrange a set of items when the order matters. So it's the number of ways you can arrange a set of items. Example 1, how do I list the permutations for a set? So we have candidates A, B, and C are in an election. I'll list all the possible permutations for how they could place first, second, and third. So we've got our first place, we've got our second place, and we have our third place. And then our candidates we've got listed as our A, our B, and our C. So first of all, we could have our A, could get first place, our B could get our second place, and the C could get our third place. Well, then we could still have A have the first place, but then we'd switch around and we could have C be our second place and B would be our third place. And now maybe in this case that we're going to have B be our first place winner, and then we might have A second place and then have C. Well, then if B is still our second place, our first place, we'd have B and then we'd have C and then A in third place. All right, and then we could have our C could be our first place, and then in second we'd have A and B. Well, then C could be in first place again, but then we could have it switched around like this. All right, so what we have here is what we consider. We have one arrangement here, two arrangements, three arrangements, four arrangements, five arrangements, and then we have six arrangements. So what this means is that I have 6 permutations. Meaning that there are 6 different ways you could arrange candidates A, B, and C getting the first, second, and third place. All right, so number 2, we have 4 siblings that are going to be in a family photo. Their names are Mac, Noah, Opal, and Piper. All right, list all the possible orders in which the photographer can line the siblings up. So we could have our Mac, and we can have then Noah, Opal, and Piper. Could be one. We could then have Mac be first again, but then it could be Opal, Piper, Noah. We could have Mac first again, and then we might have Piper first or second there, and then Noah, and then Opal. All right, and so forth. So each one of these arrangements is a permutation, and we're not going to do this one. We're not going to write them all out because there's 24 of them, and there's going to be an easier way that we're going to find that we can do this. But this is the idea of what you're looking for, is the number of arrangements that you can make. And in this case, there are going to be 24, and we'll talk about how you would find that 24 without having to list all of them out. So let's say that I decide, all right, I'm going to have D be the first person out on the stage. I had 8 contestants to pick from. And so now contestant D is out on the stage, and now I have to pick another contestant. But when I do that, let's say I'm going to pick contestant G. G is going to come over here. I only had 7 people to pick from because D was already on the stage. And so I'd have 7. Now to find out who's going to be next on stage, I would have now not 7 people to pick from, but I'd have 6. And let's say that I decided that it was going to be contestant A. And now I have to decide who's going to come out and be next on stage. Well, maybe it's going to be contestant E. Well, I chose E out of 5. We had 1, 2, 3, 4, 5. And then, and so forth. So then I'd have 4, I'd have 3, I'd have 2, and 1. And so let's say that I had F, and then the next I'd have 3 to pick from. I have B, C, and H. Well, maybe I want H to be next. And then I want B, and C. All right. So now to find the total number of arrangements, we're just going to take these numbers here and we're going to multiply them together. And that's going to tell us then how many different arrangements we would have if we had 8 people in which the order which I could put them in to perform. So if I multiply all these together, I end up getting then 40,320. All right, so I have this many permutations or this many different ways I could then arrange all of these people out on the stage. All right, question number 3. It says 7 sprinters are in the 100-meter dash. How many possibilities are there for who wins first, second, and third place? So we have 7 sprinters, and then we have first place, second place, and third place. Well, so to pick from my 7 different sprinters, I'd have 7 to pick from for first place. Well, then now because one of those sprinters got first place, I'm now only going to have 6 to pick from for second place. And because now there are 2 that have first and second here, I only have 5 to pick from for third place. So what I'm going to do here then is I'm just going to multiply these 3 numbers together. I'll take 7 times 6 times 5, and I would end up having 210 possibilities. All right, so Lacey forgot her garage code, and it starts randomly guessing 4-digit code. So her garage code is made up of 4 different numbers. Now, it doesn't say that we can't use a 0. So we have a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, 8, and a 9. So if I count up all those numbers, I have 10 numbers that I get to pick from. And there's nothing to say that I can't use a digit over and over again. So I have 10 possibilities for my first number. I have 10 possibilities for my second. My third number, I have 10 possibilities. And my fourth number, I have 10 possibilities. So when I go and I multiply all these together, I now have 10,000 different codes that I could make of these numbers, 0 through 9 for a 4 digits. So we're going to take a look at a factorial. So this is said 6 factorial, which means that the product of the integer and, so product, and remember product means multiply, and all of the integers that are below it. So if you see something written as a 6 factorial, what that means is that you have a 6, you're multiplying that times a 5, times a 4, times a 3, times a 2, and times a 1. So when you multiply all of those numbers together, you would end up then getting 720. How many ways are there to arrange 8 songs for a slideshow? All right, so what that means is that I can, I'm putting the songs in this order, and it means I could have 8 and then 7, 6, 5 to pick from in the order. So that's the 8 factorial. We can write it that way. And what that means then is that I have the 8, the 7, the 6, the 5, 4, 3, 2, and 1. So if I have 8 songs to arrange, there are 40,320 different possibilities and ways you can arrange those songs. All right, now we're going to take a look at permutation notation. All right, so let's go ahead and we're going to label this. So this n, you want to put this in your notes. This represents the total number. And then this r represents the number you want to arrange. All right, so we have the permutation here, and then this number right here means that I've got 12 numbers, and I want to arrange them 5 different ways. So starting with our 12, I'm going to have the 12, I'm going to have the 11, I have 10, 9, and I'm going to have 8. So what I'm going to do is I'm going to multiply all these together then, and I'll end up getting 95,040 when I multiply all them together. $380 different arrangements. All right, and so this lesson we took a look at how to calculate permutations.